This is fundamental problem 14 from chapter 16. In this problem, we want to determine the angular velocity of link BC and the velocity of piston C at the instant shown. They give us angular velocity AB, which we can use to determine the velocity of point B. Here, A is not moving. So if we could use equation 16-16. The velocity of A is 0, so we have the velocity of B is equal to the angular velocity of AB crossed with the position of B with respect to A. Angular velocity AB is going this way, so that's in the negative k hat direction, so that's negative 12 radians per second k hat crossed with going to point B from point A. That's going this way. The distance is 0.6 meters, so that's crossed with 0.6 meters. That's in the positive I hat direction. So I have 12 times 0.6 gives me 7.2. That's meters per second. I have this negative sign here, and k hat crossed with I hat gives me j hat. So this is in the negative j hat direction, and we know it should be going downward if the angular velocity is clockwise. So here's the velocity of point B. Now I have two things I want to find. I want to find the angular velocity of link BC and the velocity of the piston. Well, this is in the section for the instantaneous center of zero velocity. So I want to use that in this problem. So I want to find where the instantaneous center of zero velocity is when I look at link BC. Now, if you look at piston C, right before this moment in time, we had something like this, and omega AB is like this, so omega BC, that would be going like this, so the velocity of piston C would be this way. And then we come to the instant that we're looking at here, and then sometime after, we have something like this. Now piston C is going this way. So at the instant shown, piston C is as far to the right as it gets. So this is a turning point. So it was going to the right before, and right after it's going to go to the left. So at this point, the velocity of piston C is equal to 0. So that was something they asked us to find. So we found it. And now that we know the velocity at point C is 0, we can use that for the instantaneous center. And there's our instantaneous center. And going to equation 16-16, I'm looking for the angular velocity of BC. And I want to use the instantaneous center, which is at point C, so I'm just going to call that the instantaneous center, and I know the velocity of point B. So in equation 16-16, I'm going to change A to IC, and I get the velocity of point B is equal to the velocity of the instantaneous center plus the angular velocity of BC crossed with the position of B with respect to the instantaneous center. And since this is the instantaneous center, that's equal to 0. I know the velocity of point B is negative 7.2 meters per second in the j hat direction. This is equal to the angular velocity, which is what I'm looking for. But I do know the direction that angular velocity is in, so it's going this way, so that's the positive k hat direction, so that's k hat crossed with the position of B from the instantaneous center, that's going this way. That distance is 1.2 meters, and that's in the negative I hat direction. So that's crossed with minus 1.2 meters I hat. When I do K hat crossed with I hat, I get J hat, but I also have this negative sign here. So this is minus 7.2 meters per second. J hat is equal to negative omega BC times 1.2 meters J hat. Therefore, 7.2 meters per second is equal to omega BC times 1.2 meters. And that gives me the angular velocity, BC, is equal to 7.2 divided by 1.2 gives me 6, and meters per second divided by meters gives me per second, and I can stick the radians in there. And if you want to include the direction as well, this was in the K hat direction. So one other comment on this problem. Suppose that instead of thinking about what the velocity of point C is, if we weren't able to come up with this just by looking at what was going on, so let's call this C instead of the instantaneous center. So that's just equation 1616 with the A's replaced with C's. So all that I have to do here is to be able to say that whatever this velocity is, it must be going either in the positive I hat direction or the negative I hat direction. So if I did this instead, and I said this was VC I hat, and then if it's going in the negative I hat direction, I should get something negative for VC. If you know this direction for the angular velocity, this is K hat crossed with I hat. So that just gives you J hat. So the only I hat that you have in this equation would be here. So since this is the only I hat term, you must get from this VC is equal to 0. So that's another way of figuring that out.